Welcome viewers. In this video we'll see the solved problem based on the coupled circuits. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic coupled circuit solved problem 1. We'll see the statement of the problem. Two coupled coils with L1 equal to 0.02 Henry, L2 equal to 0.01 Henry and K coupling coefficient 0.5 are connected in four different ways: series adding, series opposition, parallel with both arrangement, that is adding and opposition of winding sense. What are the four equivalent inductance? So the L1 and L2 connected in four different ways: series and parallel, adding and opposition, four combination. We need to find the equivalent inductance for this four combination. The coupling coefficient is given as 0.5. So L1 equal to 0.02 Henry, L2 equal to 0.01 Henry, coupling coefficient K equal to 0.5. First we will see the series adding. Two coils are connected in series, in that the inductance are added. Series adding means that is nothing but the current enters in both the dotted end or undotted end. Then it is called a series adding. Current enters for L1 also dotted end, L2 also dotted end means adding. Otherwise L1, L2 leaves at the dotted end, means that also adding. Both should be same. In that case the equivalent total inductance is L1 plus L2 plus 2M. So first we will find the mutual inductance L, M. The formula is M equal to K square root of L1, L2. Coupling coefficient, inductance L1 and inductance L2. So all the values are already available. K is 0.5, square root of L1 0.02 and L2 0.01. So the M value after simplification we got 7.07 into 10 to the power minus 3 Henry. Now we can substitute this value: L1 0.02, L2 0.01 plus 2 into M. M is 7.07 into 10 to the power minus 3. So after simplification we got 0.044 Henry. The total inductance in case of series adding. Then series opposition. What is opposition? The current enters in dotted end in one coil, leaves at dotted end in another coil. Then it is called a series opposition. In that case total inductance is L1 plus L2 minus 2M. Here plus 2M, here minus 2M. So L1 is 0.02, L2 is 0.01 minus 2 into mutual inductance 7.07 into 10 to the power minus 3. So after simplification we got 0.016 Henry. Right. Now we'll go to the parallel connection. In that the first one is parallel adding. So here the two coils are connected in parallel. In that the current enters in the dotted end, both the current or both the coil, or the current leaves at dotted end. Then it is called parallel adding. Either current enters in dotted end or leaves at dotted end of the both the coil. Then it is adding, called connected in parallel. So in that case the total inductance is L1 L2 minus M square divided by L1 plus L2 minus 2 into M. Now substitute all the values. After simplification we got 9.4 millihenry. Milli means 10 to the power minus 3. 9.4 into 10 to the power minus 3 Henry. 10 to the power minus 3 is written as millihenry. Right. Now the fourth combination, parallel opposition. What is parallel opposition? Two coils are connected in parallel in which the current enters in dotted end in one coil. Current leaves at dotted end in another coil. So that it is a opposition. In that case the formula is L1 L2 minus M square divided by L1 plus L2 plus 2M. Adding means we got minus 2M, here plus 2M. So after substituting all the values by simplification we got 3.41 millihenry. That is 3.41 into 10 to the power minus 3. So that is written as millihenry. So in this problem the L1, L2 and K values are given. From that we calculated the mutual inductance. Then we calculate that the total inductance for 4 combinations: series adding, series opposition, parallel adding, and parallel opposition. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.